Hi, I'm Guang, 50 years old. In this lesson on limit calculation, once again, we're looking at this kind of examples here. Where from previous lesson, we've already finished method 1 of this question. And this question is, limit x approaches to 0, square root 1 plus tangent x minus square root 1 plus sine x divided by e to the power of tangent x plus a times e to the power of sine x is equal to 1 over b. And we need to find the values of a and of b. So in the last lesson, we used the method of rationalization plus L'Hopital's rule. So in this lesson, we will be taking a look at some other different methods. Alright? So let's start with method 2. And in this method, once again, we will still have to use rationalization. But this time, we will be using something different. Well, we are looking at the Maclaurin's series. Right, so rationalization and Maclaurin's series is what we are currently looking at. So what will be so special about this time? So rationalization is pretty much the same. Well, we are seeing limit x approaches to 0. And then you'll have 1 plus tangent x minus 1 plus sine x, then divided by e to the power of tangent x plus a times e to the power of sine x. And then this will be multiplied by square root 1 plus tangent x plus square root 1 plus sine x. Alright, so once again we will be substituting the x into this part behind, since it is actually a 2 and it is multiplied onto this fraction here, which we could take it out to become a half, and then we'll have limit x approaches to 0, tangent x minus sine x, and divided by e to the power of tangent x, since we pretty much already known that this would actually be a 0 over 0 form, since in the numerator it is a 0 and you have a 1 over b. So b in these questions, they won't give like b is infinity, so in order to get an actual value, it has to be a 0 over 0 form, and in order for this to be a 0 in the denominator, a has to be negative 1. Alright, so this is what we are seeing over here, a 0 over 0 form. Next, we will just be using the Maclaurin series. So Maclaurin series for tangent, you will be seeing 1 plus, is this a 1? Whoops, it's a x, not 1. And then you have to add x cubed divided by 3, and then you have all the other terms with x to the power of 5 and above, and then you have to subtract. So for sine, you're going to have x, and then you're going to have, so for sine, since you're going to have that, so you're going to have x minus x cubed over 3 factorial, and then plus little o notation x to the power of 5, and so on. And then here in denominator, what you're going to use is the Maclaurin series for E. So Maclaurin series for E, what you can also use on this is actually to bring out the e to the power of sine x first. And then you're going to have e to the power of tangent x minus sine x. Well, then you can use your Maclaurin series on e to the power of tangent x minus sine x. So what will that be? So first off, it will be a tangent x minus sine x, and then you're going to add tangent x minus sine x squared divided by 2, and then so on. Alright, so since at first there was a 1, and then it will just be subtracted by this 1. Alright, so essentially this is the term that we are going to see. Alright, so let's take a look at how we can continue from this step. So in this case, what we will have next is you have this tangent x minus sine x also in the denominator. Then e to the power of sine 0 is basically a 1. So you're going to have half limit x approaches to 0. And in the numerator, x, they cancel out. You can put the x cubes together, and you have 1 over 3 plus 1 over 3 factorial x cubed. And then you'll just have all the other higher power of x. And then this is divided by. So tangent x minus sine x, what you can do is basically the same things, alright? So it will just be from what we have gotten before. X cubed, and then plus the dual notation x to the power of 5, and so on, alright? So then from this step, you'll realize both numerator and denominator will actually be the same, since whatever you have behind higher powers of x, when you just divide x cubed, they will just basically all become 0. Well, the only terms that matter will be the terms of x cubed, which are actually the same, and thus this will give you a half. But we're given that this is 1 over b. So what we're going to have is a is equal to -1 and b is equal to 2. Right, so this is the second method using rationalization and the Maclaurin's series. So take a look at this once again. And next we will be taking a look at the third method. Alright, so now let's take a look at how method 3 is going to work. So what is method 3 going to be about? This will be rationalization with substitution. And finally, it will just be combined with the special limit. Alright, so this is what method 3 is going to have. So once again, rationalization, we can just take what we actually get from here, where you're going to see half limit x approaches to 0, tangent x minus sine x divided by e to the power of tangent x minus e to the power of sine x. Right, so now how is this substitution part going to work? So the kind of substitution we're going to make is just going to be let, but what are we going to let? Let tangent x minus sine x be something called u. So when x approaches to 0, u is going to approach to 0. Alright? So there's going to be half limit u approaches to 0. The numerator becomes u, but what happens to the denominator? So the denominator, originally you have this part, but then I can take out e to the power of sine x. Alright? So you take out e to the power of sine x, then you're going to have e to the power of tangent x minus sine x minus 1, and then e to the power of sine x, you substitute x inside to get 1. Alright? So at first, this will be e to the power of tangent x minus sine x, and now it becomes a u, e to the power of u. So e to the power of u, then you have a minus 1. Alright? So you'll see this term here, but then how are you going to continue from here? So next part, we're going to have to let once again what are we going to let this time? This will be e to the power of u minus 1 be equal to v. So now v will approach to 0 also, alright? So half limit v approaches to 0. U, how is u going to change? U is going to be v plus 1 and then ln. So we're going to have ln 1 plus v. And this is divided by v. So let's change it a little bit, shall we? This will be half limit v approaches to 0 ln 1 plus v to the power of 1 over v. Since this over v would actually be a 1 over v multiplied onto ln, which then can be put up into the power as 1 over v. Do you recognize anything familiar from here? V approaches 0, you're going to have ln, and this is a 1, but then you have a power of infinity. So what's so special about here? This here will be where you use the special limit. Since you already have the form of the special limit, you're going to have half ln e, which will just give half. And since in the question we're given that this is equal to 1 over b, once again a is equal to negative 1, b is equal to 2, alright? So there we have it, 3 different methods, and we all have the same answer. But the thing about all these 3 methods is that they will make use of rationalization, since the root with the trigonometry in the numerator will be a bit more complicated if you just want to directly use L'Hopital's rule or something, alright? So that is pretty much it for this lesson, where we took a look at the second method and the third method. Well, in the second method, we use rationalization plus the Maclaurin's series. And this is what we have, and at last, it gives us a half. Well, for the third method, we just use rationalization together with substitution, together with the special limit. Well, substitution, you make 2 times of substitution, or if you could see it together, you could just let e to the power of tangent x minus sine x be equal to u or something, and then you only need to use, and also because you need minus 1, so if you let e to the power of tangent x minus sine x minus 1 be equal to u or something, then you only need to use substitution 1 time, alright? But otherwise you can just use it twice and then find that it is a special limit, and then you get your final answer. Right, so I hope for this lesson you're clear of these 2 methods so far, and I'll conclude the 3 methods for this example here. Right, so we end this lesson here, and thank you for your watching.